Hello everyone, welcome to the third video on the TopSpin software tutorial. In this video, I'm going to be showing you how we can define your multiplets by region and how we can find out their coupling constants. Coupling constants are a measure for the spin-spin interaction between nuclei. They are represented by the frequency difference in hertz between your multiplet peaks. Without any further ado, let us go to the TopSpin software. I'm going to be using the NMR for ethanol as an example for this video. Once I have my NMR opened up, the first thing I should always do is to calibrate it. For this experiment, I used chloroform as the solvent, and I know that the chemical shift for chloroform is 7.26. Here it is showing 7.2797 as the chemical shift, which is slightly higher. So in order to calibrate it, I'm going to go to the bottom left of my software in the command box and type .cal and press enter. Once I do that, I'm going to go to the peak of my chloroform and left click once and type in the correct chemical shift value for it, which is 7.26, and press OK. Once I've done that, now my NMR is calibrated and I can begin working on my multiplets. First, I'm going to zoom in on the region of my multiplet by dragging my mouse across. And here, as you can see, I've got three distinct regions. On the left over here, I have a quartet with 4 peaks. In the middle, I have a singlet with just a single peak. And on the right, I have a triplet with 3 peaks. First, I'm going to define my quartet, which is on the left here. So in order to work on my quartet, I'm going to first zoom in on that region. And now I'm going to go to the Analyze tab in the top left of my screen. Under the Analyze tab, I'm going to go to Multiplets. I'm going to click on it. And now, in order to define this quartet, I'm going to click on the icon, which is third from the left. It looks like a splitting flowchart, and it says Define Multiplet by Region. I'm going to click on it once. And now that I've clicked on it, I'm going to drag my mouse across this quartet. And when I release it, on the top right corner, as you can see, it shows the chemical shift values as well as the coupling constant, J, for my quartet. Here it is showing the chemical shift value of 3.6656. That is the midpoint of the chemical shift values for this quartet. And below, it also shows M equals 4, meaning that this has 4 peaks, and hence it is called a quartet. Beside it, the coupling constant value J is 7.0314 Hertz. To save my work, I'm going to click on the icon, which is second from the right, and says Return and Save Multiplets. I'm going to click on this icon once. Now I'm going to go back to my screen, and I can start working on the triplet in my NMR. I'm going to zoom into the region of my triplet, and I'm going to repeat the same process again. I'm going to go under the Analyze tab in the Multiplet section, and I'm going to click on the third icon from the left, which says Define Multiplet by Region. It looks like a splitting flowchart. Once I've clicked that icon, I'm going to drag my mouse across my triplet. And once I've done so, in the top right corner, you can see that it shows the chemical shift of the triplet. Here it shows 1.1965, which is the midpoint value of the chemical shift. And below it, it shows M equals 3, meaning that this multiplet has 3 peaks, hence it's called a triplet. And it also shows the coupling constant J, which is 7.0825 Hertz. Once I have these values, I am going to save my work again by clicking on the icon, which is second from the right side. It says Save, Return and Save Multiplets. Once I click on it, I'm going to go back to the full view of my NMR. I'm going to zoom in on my multiplet regions again. And now, since I have already defined my multiplets and saved my work, if I want to view the values of the coupling constants and the chemical shifts again, all I have to do is go to the Analyze tab and click on Multiplets. Once I click on multiplets, it is going to automatically show up the saved values of my quartet or my triplet. Here currently, it is showing chemical shift value of 3.6655, which is the chemical shift for my quartet on the left side of my screen. I can be sure that that is the quartet because right under it, it shows M equals 4, meaning that it has 4 peaks. Hence, that is the value for my quartet. And if I want to view the chemical shift and the coupling constant values for my triplet, which is on the right side of my screen, then I can do that since I've already saved it previously by clicking on the icon with the letter M, and it has an arrow above it pointing to the right, and it says select next multiplet. Once I click on it, it is going to now toggle and show the values of chemical shift and coupling constant for my triplet, which was saved previously. Again, if I want to go back to viewing the values of my quartet, I'm going to click on the icon which is right beside it with the arrow pointing to the left. It says select previous multiplet. And in this way, you can go back and forth into viewing the chemical shift and coupling constant values of your multiplets in the NMR. If, for some reason, let's say you made a mistake when defining the multiplet region, you can get rid of those values by clicking on the icon which looks like a cross. It says remove selected multiplet. Right now, it is showing on the top right corner M equals 3, meaning the triplet. So right now it is showing the values for my triplet. If I want to get rid of these values, I'm going to click on the cross icon, and that is going to delete its values. Similarly, if let's say I made a mistake in defining all my multiplets in my NMR, then I can also get rid of all the multiplets in my NMR by clicking on the icon right beside it. It says remove all multiplets. Clicking on this icon will get rid of the data for all the multiplets in my NMR. If I click on it, now it does not show anything on the top right corner of my NMR, meaning that the data of the chemical shift and the coupling constants for all the multiplets in my NMR have been deleted. To save my work, I'm going to again click on the return and save icon, which is one from the right side. In this way, you can define the multiplets in your NMR by region and calculate their respective coupling constants. Thank you so much for watching this video. In the next video, I will be showing you how you can stack multiple NMRs using the TopSpin software. You can stack the NMRs for your starting material and the product in the same page, which will allow for better comparison.